Good evening, students. Today we are going to discuss the topic continuity and differentiability. First, we can define continuity. Here, we can define continuity by using a graph. Let us consider the function as a continuous function. Here, we can considering the graphical representation. This type of graph, that is here, the function is moving smoothly. That means it is a curved graph and it is also a continuous graph. That means it is moving continuously. Let us consider the point A and B on x-axis. Here the function f of x is continuous on the point A and B. That means it has no break point. It is moving continuously. That is the continuity of the function. Let us consider another graph. The graph has here. Consider another graph. The second graph has a discontinuity will be appearing at the point. Let us consider the point x equal to 2. The graph has broken. That means it has break point at x equal to 2. Therefore, this function is not continuous function and it is a discontinuous function, and therefore the function is not continuous at the point x equal to 2. Simply we can say the continuous function has moving continuously. Some basic ideas about the continuous function. Let us consider it. Some functions are always continuous. Here, the first considering polynomial functions conditions. Here, the polynomial functions are always continuous. Polynomial functions are always continuous. That is, it is always continuous function. What is polynomial functions? We know that the polynomial functions are of the form 3x plus 1, x square plus 3x plus 2, then x square plus 5x plus 6, like that. That is, these type of functions are always continuous. And the trigonometric functions, let us consider the trigonometric functions. Second condition, the trigonometric functions are always continuous. Here the trigonometric functions are what? Sin x, cos x, like that. That is, for example, sin x, cos x, etc. These are also continuous function. Next we can consider an inverse trigonometric functions. Inverse trigonometric functions are always continuous. Always continuous. What are the inverse trigonometric functions? Like that, sine inverse of x, cos inverse of x, tan inverse of x, like that. These are always continuous function. That is, these three functions are always continuous. First one, the polynomial functions are always continuous, trigonometric functions are always continuous, and the inverse trigonometric functions are always continuous. Next, we can define properties of continuous function. If f of x and g of x are continuous, first property, f of x plus g of x is always continuous. Then second property, f of x minus g of x is always continuous. Third property, f of x into g of x is always continuous. And the fourth property, f of x by g of x, it is also continuous. That is, if f of x and g of x are continuous function, therefore f of x plus g of x is always continuous, f of x minus g of x is always continuous, f of x into g of x is continuous, then f of x divided by g of x is continuous. Next we can consider another property. That means here f of x and g of x are two continuous function. We can considering the composition of these two functions. That is, f composition g is always continuous and g composition f is always continuous. How can we define f composition g and g composition f? Let us consider the two functions f of x equal to sin x and g of x equal to x square. Therefore, f composition g of x, how can define? That means f of g of x. Therefore, f composition g of x can be written as f of g of x. Here, the function f of x is defined as sin x. Therefore, we can put g of x inside the function f of x. That means here f of x is sin x. Therefore, g of x is x square. Therefore, f composition g of x is equal to sin of x square. That is sin x square. This is always continuous because it is the composition of two continuous function. That is f of g of x is always continuous. Next we can considering decomposition f of x. Decomposition f of x, how can define? It is equal to g of f of x. That implies here g of x is x square. Here we have to put the function f of x in g of x. That means g of f of x can be written as g of x into f of x equal to g of f of x. That means here f of x is sin x and g of x is x square. Therefore, g of f of x, that is f of x the whole square, that is f of x is sin x, that is sin x whole square. It is also continuous function because sin x and x square are continuous. Here sin x is a trigonometric function and g of x, it is x square. X square is a polynomial function. Therefore, both of them are continuous function. That's why g of x and f of x are continuous. Therefore, f of g of x is always continuous and g of f of x is always continuous. That is, the composition of these two continuous functions is also continuous.
Next, we have to define continuity at a point. Now here, let us consider the function f. Let f be a real valued function, and c be any point in the domain of f. Then f is said to be continuous at c if limit x tends to c, f of x exists, and limit x tends to c, f of x equal to f of c. That is, here f be a real valued function and c be any point in the domain of the function f, then f is said to be continuous at point c if limit x tends to c, f of x exists. That is, the limit value will be exist and that will be equal to limit x tends to c, f of x will be equal to f of c. Let us consider the example. Prove that the function f of x equal to 5x minus 3 is continuous at x equal to 5. How can we find out? First, we have to find out the value of f of x at x equal to 5. That is here given the solution. Here given f of x equal to 5x minus 3. Then next we have to find out the value of f of x at x equal to 5. That is, here we have to find out f of 5 equal to what? 5 into 5 minus 3, that's equal to 25 minus 3 equal to 22. Next, by the definition of continuity at point 5, how can we define? Here limit x tends to 5, f of x. What is the value of limit x tends to 5, f of x? Next, we can check limit x tends to 5, f of x. That is equal to limit x tends to 5. The f of x value will be 5x minus 3. That is equal to what? When x value will be 5. Therefore, the value is 5 into 5 minus 3. That's equal to 25 minus 3 is equal to 22. That is, here limit x tends to 5, f of x equal to 22, and the value of f of 5 is also equal to 22. That means what? The limit x tends to 5, f of x is equal to f of 5. Therefore, f is continuous. That is, here limit x tends to 5, f of x equal to what? 22. It is also equal to what? F of 5. That is, the value of f of 5 is 22 and limit x tends to 5, f of x is 22. That means what? Limit x tends to 5, f of x is equal to f of 5. Therefore, f is continuous at x equal to 5. Next, consider the question. F of x equal to 2x square minus 1 if it is continuous at x equal to 3. Check if it is continuous at x equal to 3. How can we check? First, we have to find out the value of f of 3. That is, here given f of x equal to what? 2x square minus 1. Then f of 3 will be, put x equal to 3 in this given equation. That is 2 into 3 square minus 1. That's equal to 2 into 9 minus 1. That is 18 minus 1 equal to 17. Then next we can consider the function is continuous at the point x equal to 3. That is, here we have to find out limit x tends to 3, f of x equal to what? Limit x tends to 3, here f of x is 2x square minus 1. That implies it is equal to, when x value will be 2, 2x square minus 1, that is 2 into 3 square minus 1, that's equal to 2 into 9 minus 1, that's equal to 18 minus 1 equal to 17. That is, here the limit x tends to 3, f of x will be equal to what? F of 3. Therefore, f is continuous at x equal to 3. Next question, prove that the function f of x equal to x raised to n is continuous at x equal to n, where n is positive integer. That is, here the given function is what? Here the given function is f of x equal to x raised to n. Here one condition is given, n is a positive integer. That means n belongs to natural number system. N is always positive integer. Then that implies, next we can find out f of x is continuous at x equal to n. That is why here we have to find out f of n. F of n equal to n raised to n, where n belongs to capital N. That is, n belongs to positive integer means n belongs to natural number system. Then next we can consider the limit x tends to n f of x. What is the value of limit x tends to n f of x? Here limit x tends to n f of x is x raised to n. That is equal to n raised to n. That implies n belongs to n. That is, here what? Limit x tends to n f of x is equal to f of n. F of n is also equal to n raised to n. That implies what? Here f is continuous at, therefore f is continuous at x equal to n, where n belongs to natural number system. Next question, let f from R to R be defined by f of x equal to greatest integer function x, where the greatest integer function x denote the greatest integer less than or equal to x if f is continuous at x equal to 0. That is, here the given function is greatest integer function. That is given f of x equal to greatest integer function x. So here we have to find out the function is continuous at x equal to 0. In the case of greatest integer function, here we have to consider the left side of 0 and the right side of 0. That is, the greatest integer belongs to the left side. How can find out? Now here we have to find out the two interval, that is left side of 0 and right side of 0. Here the left side of 0 is left hand limit and right side of 0 is right hand limit. That means here the left side is the limit x tends to 0 minus, and the right side is limit x tends to 0 plus. First we have to find out limit x tends to 0 minus f of x. That is equal to, the function can be defined on two intervals, that is left side of 0 and the right side of 0. The greatest integer function is the greatest integer less than or equal to x. Now here limit x tends to 0 minus f of x. That means here less than 0. That means it is also denoted by limit h tends to 0, the greatest integer function 0 minus h. That is left side of 0. That is decreasing. That is, it can be denoted by limit h tends to 0, 0 minus h. That is equal to, that means this is belongs to the greatest integer less than or equal to x. Next, greatest integer less than or equal to x, that is minus 1 is here. Therefore, limit h tends to 0, the greatest integer 0 minus h. That means it is equal to minus 1. Then next we can find out the right hand limit, limit x tends to 0 plus, that is limit x tends to 0 plus f of x equal to limit h tends to 0, here increasing the point h, that is 0 plus h, that is equal to, here the greatest integer function less than or equal to x, that means it is equal to 0. That is between this interval less than greatest integer function less than or equal to x, that is it will be 0. Therefore, the limit x tends to 0 plus f of x equal to 0. That is, here the left hand limit, limit x tends to 0 minus f of x not equal to limit x tends to 0 plus f of x. And also here we have to find out f of 0 is what? It is 0. That is, it is not equal to f of 0. That means the function is not continuous at the point x equal to 0. Therefore, f is not continuous at f equal to Therefore, the function is not continuous at x equal to 0. That is, in this case, that intervals are given. Therefore, here we have to define the function in two intervals. That is, one is less than the limit and another one is greater than the limit. That is why here we have to find out the left hand limit and right hand limit. If it is equal, the left hand limit and right hand limit will be equal to the continuity at a point, given point. That means the function is continuous. Next, consider the question f of x equal to x if x less than or equal to 1 and f of x equal to 5 if x greater than 1. Find the continuity at x equal to 1. Now here we have to find out the function f of x is continuous at a point x equal to 1. In this question, the function can be defined on two intervals. That means f of x equal to x when x less than or equal to 1, that is at x equal to 1 this point, then including this region the function is f of x equal to x. Next, the function can be defined f of x equal to 5 x greater than 5. Here we have to check the function is continuous at x equal to 1. If it is continuous, now here less than or equal to 1 it is x, greater than 1 it is 5. That is, here we have to find out left hand limit and right hand limit. Then left of 1, that is limit x tends to 1 minus f of x can be calculated, and the right of 1 we have to consider limit x tends to 1 plus f of x. Then finally we have to find out at a point x equal to 1 the function is continuous or not. Now here the function is defined on f of x equal to x, x less than or equal to 1 this point. Then next we can consider x greater than 1. That means this point will be breaking. Normally it will be breaking. Then how can we check? We have to define limit x tends to 1 minus f of x and limit x tends to 1 plus f of x value will be equal. We have to say the function is continuous at the point x equal to 1. First, we have to check the left hand limit, that is limit x tends to 1 minus f of x is equal to what? Limit x tends to 1 minus f of x is x, that's equal to 1. That is, if x less than or equal to 1, the value will be x. Therefore, here limit x tends to 1 minus, that is the left hand limit at x equal to 1. Then limit x tends to 1 plus. Next, we have to consider the right hand limit f of x. It is equal to limit x tends to 1 plus. Here the function is 5. That is, if x greater than 1, f of x is 5. That's equal to 5 itself. It's a constant function. Therefore, here limit x tends to 1 minus f of x is equal to 1 and limit x tends to 1 plus f of x is 5. That means limit x tends to 1 minus f of x, that is the left hand limit, not equal to limit x tends to 1 plus f of x. That is the left hand limit not equal to right hand limit. That means the function is not continuous at the point x equal to 1. That is the left of 1 it is defined f of x equal to x, and right of 1 it is defined f of x equal to 5. That means the point at point x equal to 1, what is the value of f of x? F of 1 equal to 1. That means the limit x tends to 1 minus f of x not equal to limit x tends to 1 plus f of x. That means the left hand limit not equal to right hand limit. It means the function f is not continuous at x equal to 1. Next, consider the question. Consider the function f of x equal to x square minus x minus 6 divided by x plus 2, where x not equal to minus 2. If x equal to minus 2, this function does not exist. That means the denominator will be 0. That's why x not equal to minus 2. And when x equal to minus 2, the value will be minus 5. That is, f of x is minus 5 when x equal to minus 2. First question, what is the value of f of minus 2? That is given here, f of minus 2 is minus 5. It is given. For the first question, it is given here f of minus 2 equal to minus 5. Next, we can check the function is continuous at x equal to minus 2. That means how can we find out? Here we can consider limit x tends to minus 2 f of x. What is the value of f of x here? Limit x tends to minus 2. That means it is not equal to minus 2. It is tends to minus 2. That means function is what? X square minus x minus 6 divided by x plus 2. That is here x tends to minus 2, not equal to minus 2. That is, it is equal to limit x tends to minus 2. F of x is x square minus x minus 6 divided by x plus 2. That is equal to limit x tends to minus 2 x square minus x minus 6. That is, here it is of the form x square plus a plus b into x plus ab. That means the coefficient of x is the sum of the root. Here a plus b will be equal to minus 1 and the product ab is equal to minus 6. Therefore, what is the value of a and b? Now here it is equal to minus 3 plus 2 equal to minus 1, minus 3 into 2 equal to minus 6. Therefore, the factors are x minus 3 into x plus 2. Therefore, limit x tends to minus 2, x square minus x minus 6 can be written as x minus 3 into x plus 2 divided by x plus 2. Now here x plus 2 cancel. That implies limit x tends to minus 2, x minus 3. That is equal to limit x tends to minus 2, x minus 3. That is minus 2 minus 3. That is equal to minus 5. That is here limit x tends to minus 2 f of x equal to minus 5 and f of minus 2 is also equal to minus 5. That means what? Limit x tends to minus 2 f of x equal to f of minus 2. That means it will be equal. Therefore, the function f is continuous at x equal to minus 2. Next, we have to define the continuity of a function on open interval AB. How can we define the continuity on open interval AB? That means the function continues on every point on this interval. That is, here the function is continuous when limit x tends to a plus, that is the right of a, f of x is equal to f of a will be exist, and limit x tends to b minus, then the left of b, then f of x, limit x tends to b minus f of x is equal to f of b exists. Therefore, we can say the function is continuous on an open interval AB. Next, we can consider the properties. Let f and g are two continuous functions. Then first one, limit x tends to c f of x plus g of x. That is, here f and g are two continuous functions. That means limit x tends to c f of x equal to f of c will be exist, and g be a continuous function. That means limit x tends to c g of x equal to g of c. Therefore, the sum of these two continuous functions, that is limit x tends to c f of x plus g of x, is equal to limit x tends to c f of x plus limit x tends to c g of x. That is equal to what? F of c plus g of c. It is a continuous function. That means here limit x tends to c f of x equal to f of c exists. Therefore, the function is continuous at the point c. And limit x tends to c g of x equal to g of c. That means the function is continuous at the point c. Then the sum of these two continuous functions is again continuous. Next, second point, limit x tends to c f of x minus g of x. That is equal to limit x tends to c f of x minus limit x tends to c g of x. Here f of x and g of x are two continuous functions. Therefore, limit x tends to c f of x equal to f of c exists, and limit x tends to c g of x equal to g of c exists. That is, the function is continuous at the point x equal to c. Therefore, limit x tends to c f of x minus g of x equal to limit x tends to c f of x minus limit x tends to c g of x equal to limit x tends to c f of x, that is f of c minus g of c. That means the function is continuous at c. That is, here limit x tends to c f of x plus g of x is f of c plus g of c. Here also f is continuous at x equal to c. Next, third properties. Let alpha be any real number, then alpha into f of x, that is limit x tends to c alpha f of x, it is equal to alpha into limit x tends to c f of x. Here f is continuous at a point c. That means limit x tends to c f of x equal to f of c exists. Therefore, the function f is continuous at a point c means limit x tends to c f of x equal to f of c. Therefore, limit x tends to c alpha into f of x equal to alpha into limit x tends to c f of x, that is equal to alpha into f of c. Therefore, the function f is continuous at x equal to c. Next, fourth one, f of x and g of x are two continuous functions. That for f of x and g of x is continuous at a point c. That is limit x tends to c f of x equal to f of c and limit x tends to c g of x equal to g of c exist. Therefore, the limit x tends to c f of x into g of x. It is equal to limit x tends to c f of x into limit x tends to c g of x. That is equal to limit x tends to c f of x. It is f of c into limit x tends to c g of x. That is equal to g of c. Here f is continuous at x equal to c. Next, we can consider the function is of the form f of x by g of x. Let us consider the function limit x tends to c f of x divided by g of x. That is the function is of the form f of x by g of x. That is a rational functions. Then how can find out the continuity? That is limit x tends to c f of x by g of x is equal to limit x tends to c f of x divided by limit x tends to c g of x. Here g of x not equal to 0. Limit x tends to c f of x divided by limit x tends to c g of x. That is equal to what? Limit x tends to c f of x. That is f of c divided by g of c. Here g of c not equal to 0. Therefore, limit x tends to c f of x by g of x equal to f of c by g of c. That means the function is continuous. F is continuous at x equal to c. Next question. Find all points of discontinuity of f where f is defined by f of x equal to 2x plus 3 if x less than or equal to 2, 2x minus 3 if x greater than 2. Here given f of x equal to what? 2x plus 3 if x less than or equal to 2 and 2x minus 3 if x greater than 2. That is here f of x is 2x plus 3. It is a polynomial function. Then again 2x minus 3. It is a polynomial function. If x less than or equal to 2 and x greater than 2, f of x is a polynomial function. That is why f of x is continuous polynomial function. Therefore, f of x is continuous. Here, x less than or equal to 2 and x greater than 2, f of x is a polynomial function. That is why f of x is continuous. Next, we have to check f of x is continuous at x equal to 2. That is here, left hand limit and right hand limits are continuous because it is a polynomial function. Next, we can check at x equal to 2 if f is continuous or not. That is why here we have to find out the left hand limit and right hand limit. At x equal to 2. First we can check limit x tends to 2 minus f of x. What is that? 2 minus f of x. That is x less than or equal to 2. F of x is 2x plus 3. Therefore, equal to limit x tends to 2 minus f of x is 2x plus 3. That is equal to what? Limit x tends to 2. What is the value? 2x plus 3. That is 2 into 2 plus 3. That's equal to 4 plus 3 equal to 7. Next, we can consider the right hand limit. Limit x tends to 2 plus f of x. It is equal to what? Limit x tends to 2 plus f of x is what? 2x minus 3. That is equal to 2 into 2 minus 3. That is 4 minus 3 equal to 1. Here, the left hand limit x tends to 2 minus f of x is 7 and right hand limit x tends to 2 plus f of x, it is equal to 1. That is here, the left hand limit is not equal to right hand limit. Therefore, we can say at x equal to 2, the function f is not continuous. That is at f equal to 2, what is the value? It is 7. That is limit x tends to 2 plus f of x not equal to limit x tends to 2 minus f of x. Therefore, f is not continuous at x equal to 2. Find all discontinuity of f where f is defined by f of x equal to mod x plus 3 if x less than or equal to minus 3, minus 2x if minus 3 less than x less than 3, 6x plus 2 if x greater than or equal to 3. That is, here the given function f of x is a polynomial function. Here we have to consider when x less than or equal to minus 3 and x greater than or equal to 3. Here the domain lies between minus 3 and 3. That is, x belongs to open interval minus 3, 3. That is, here first we have to check at x equal to minus 3 the function is continuous or not. First one, for x less than or equal to minus 3, f of x is what? F of x equal to mod x plus 3. Second case, for minus 3 less than x less than 3, f of x is equal to minus 2x. Then for x greater than or equal to 3, f of x equal to 6x plus 2. That is, if x less than minus 3, that is, here x belongs to open interval minus 3, 3. The function defined on the domain open interval minus 3, 3 and x greater than 3. F of x is what? X greater than or equal to 3. F of x is 6x plus 2. That is, it is also a polynomial function. Here, all these functions, that is, if x less than minus 3 and x greater than 3, f of x is a polynomial function. Here, the given function f of x is a polynomial function. Therefore, f of x is continuous. Therefore, f of x is continuous. Next, we can check point-wise continuity. That is, first we can check at x equal to minus 3, the left-hand limit, that is, limit x tends to minus 3 minus f of x. That is the left side of the function. That is, here we can consider limit x tends to minus 3. If x less than or equal to minus 3, what is the function? Function is mod x plus 3. We know that the modulus function, how can we define mod x equal to minus x if x less than 0, 0 if x equal to 0, then x if x greater than 0. The same manner here, x less than minus 3, that is minus x. Mod x can be minus x. That is, then it can be written as it is equal to limit x tends to minus 3 minus x plus 3. That is equal to, here limit x tends to minus 3, minus of minus 3, that is minus of minus 3 plus 3, that is equal to minus of minus 3, that is plus 3, that is 3 plus 3, that is equal to 6. That is limit x tends to minus 3 minus, that is the left hand limit, it is 6. Next we can consider the right hand limit at x equal to minus 3. That is limit x tends to minus 3 plus f of x, that is the right side of minus 3, the function. What is that? It is equal to, that is, here the function defined minus 3 less than x less than 3. That is, here x lies on the right of minus 3. Therefore, the function is f of x equal to minus 2x. That is, limit x tends to minus 3. Here, the function f of x is what? Minus 2x. It is equal to limit x tends to minus 3 minus 2x. That is minus 2 into minus 3. That is equal to 6. Here, limit x tends to minus 3 minus f of x equal to limit x tends to minus 3 plus f of x. That is, here the left hand limit and right hand limits are equal. Next we can consider also f of minus 3 is equal to what? That is, here f of minus 3. That is, if x less than or equal to 2. First question, that is, here the first case what? If x less than or equal to minus 3, the function is mod x plus 3. That is f of minus 3 what? Modulus of minus 3, that is 3. That is, f of minus 3 can be written as modulus of minus 3 plus 3. That is equal to what? 3 plus 3 equal to 6. That is, limit x tends to minus 3 minus f of x equal to limit x tends to minus 3 plus f of x equal to f of minus 3. That means f is continuous at x equal to minus 3. Next, we have to check at x equal to 3, the function is continuous or not. First, we can check at the left of 3, that is, here the function f of x is equal to minus 2x if x less than 3. That is, limit x tends to 3 minus f of x equal to what? Limit x tends to 3 minus f of x is minus 2x. That is equal to limit x tends to 3. What is the value? That is equal to minus 2 into 3. It is equal to minus 6. Next, we can consider the right hand limit. Limit x tends to 3 plus f of x. What is the function? X greater than or equal to 3. The function is 6x plus 2. That is limit x tends to 3 plus the function what? 6x plus 2. That is equal to limit x tends to 3, 6x plus 2. 6 into 3 plus 2. That is equal to 18 plus 2 is equal to 20. That is here limit x tends to 3 minus f of x not equal to limit x tends to 3 plus f of x. That is limit x tends to 3 minus f of x is minus 6 and limit x tends to 3 plus f of x is 20. That is limit x tends to 3 minus f of x not equal to limit x tends to 3 plus f of x. Therefore, f is not continuous at x equal to 3. Not continuous at x equal to 3.